Okay, let's get started. Huh? On the side here. Okay. All right. So we went through quite a long series. Like scope management is actually a very big topic here. In fact, in project management, what we do is we spend a lot of time on scope management, because other things like risk, other things like occupational health and safety, and organization behavior, which is dealing with team, and also communication management. Those are actually more or less covered in more or less already covered in other subjects. And quality, there's going to be a whole series of topics on quality management. So we really spend time here for this particular subject, project management, on very core we spend a lot of time on things like the typical very core things like scope, time, cost, okay, procurement. Even procurement, we will be spending time on procurement here, but we later on will be spending a lot of time also on procurement in terms of contract and all that as a separate subject, which is going to be taken by myself as well next semester. Okay, so yeah, so scope management, we spend a lot of time, and then you'll be this week, and then next week, Dr. Lee will be taking you for engineering economics, and I'll be also posting some pre-recorded lectures on LU6. I think LU6 is pre-recorded lectures that is going to be on life cycle costing and also value engineering. So that two topic, it won't be very long. It will be like about just an hour kind of pre-recorded lecture, and I'll leave you with some little homework to do in that way, to make sure that you actually understand what is the gist of it there. Okay, so we went through like scope up to scope. We went through up to scope planning. So just to recap a little bit, so we've already done our project environment study. What will be affected by the project, and what would the project affect later. And then and what will affect the project, and what the project will affect later. So we went through that, and from that particular study, we actually would like to express our idea, okay, in what we call a project charter. So in this project charter, what we're going to have is like what you're going to build or what you're going to do. It's like a concept of the product itself, actually, if we could put it that way. Okay, so once the concept of the product, meaning that you're going to build a bridge, it's going to be a 2-lane bridge, is it going to be a highway, it's going to be running from point A to point B, so we're going to build a jetty at which location, is it, and it's going to be a big jetty, small jetty. So that kind of things are what we're going to have, what we're going to put in here in the project charter. It's more of a description of information. So with this project charter, you're going to be collecting more information. You're going to do a lot more technical studies, initial investigation, and then we're going to proceed with the actual planning stage of the scope. When we look at project, you have to know there's 2 layers here. One layer is the product itself. Like, let's say you're going to build a factory, you're going to build a new production line, or is it a new product, like maybe a new polymer or something. And then for civil engineers, we're going to build like a lot of facilities. So all these are the product. So the product itself needs to be described as well. So once you've got the product and all the subcomponents of the product, and this is where we are actually looking at in the project charter, is really Okay, sorry, Africa was a bit noisy just now. I just muted her. Yeah. Okay, so yeah, like like I said, the project charter is basically to specify the idea or specify the product itself. You see, specify the scope, a bridge, a submarine, a new departmental stores, a new research project, a new polymers, those sort of things are what we talk about in terms of project charter. Project charter would not be a very big document. It would be just a descriptive documents of what it may involve some sort of drawings. It's just like your concept basically being presented there. So then now when we get into scope planning, you see, scope planning is like you've got all the little components ready now. Okay, like you've got your product and their subcomponents. If we talk about, let's say, simple things like a laptop. Okay, if we're gonna, our project charter would say that we are going to be building a laptop. We'll be specifying some of the requirements of the laptop and what the laptop can do, and what the laptop seek to resolve, and where does the idea come from, and where is who is the client and the people wanting to use this particular product, and how are they going to use it to solve problem, what sort of problems they want to use it for, and all that. So then after that, in your project charter, you will also list down some components, like some components. Okay, the laptop will have a central CPU, it have a screen, it has camera, it has battery, you see. So you've got all these subcomponents. It's just like when we are building a bridge, you've got your foundation, you've got your piling, you've got your column, bridge column, you've got your bridge structure, the road, traffic, etc. So you've got that. You see the components. So once you've got these components, these are actually still in the product level. You're still describing it in the product level. Then when you come to scope planning, in order to come up with every single one of these product, okay, you'll be looking at activities that you need to do in order to resolve, in order to get to this product. And this is at this layer onwards, or this level onwards, we're looking at project definition. So besides looking at the components, we also will be looking at the works, how to describe the works to be carried out. That means the scope of the project that needs to be done, like the activities that needs to be done, and all the processes, the works, the activities, the task that needs to be done in order to complete the components, in order to finish up the component. So the description of the project works, so it's like this is description of the project works now that we're looking at. And that is, and we normally would go into using this sort of like work breakdown structure. At this stage where you talk about work breakdown structure, it may not, if it's a very simple project, then yeah, we could actually do quite a good work breakdown. Like for example, your product breakdown, at this stage in your product breakdown, you could actually look at product breakdown can be used to describe the project charter level. Then the work breakdown, will be using it mostly to describe the project definition. So the scope of works, you see the key things here is works, W-O-R-K-S, works is the activities, is the task that needs to be done. So we could describe it together with the components. We could actually, like for example, if I want to do piling, I would think that the major things that needs to be done in the piling is the selection of the piles itself, and then you need to talk about drilling, you need to talk about pouring. It's just an idea of what the works will be at this stage, because the components of the project, like I say, is a rough idea. So the work that goes into it at this stage, we are still going to develop it further. Okay, so once this product definition is done, okay, once the product definition, once the works definition is done, so like our product and processes deconstructed into manageable components. So you see, like you've got all your subcomponents of your product, and then how you're going to achieve every one of these subcomponents, and the works and the processes that needs to go into every one of these subcomponents. If you're in a factory environment, it's exactly the same thing as well. It's just that you have you want to construct a product, you need to go, line A. What does line A do? What does line B do? What does line C do? You see, and then from line C, what is the main activities for line C, and what are the main activities for line B? And then we are trying to construct that at this stage, okay? And yeah, I mean, like, the thing is, once we've got this, then we can really start to define time, cost, quality, and all that. So without that, we cannot, we would not be able to run these components. Huh? Okay. Can you guys give me a minute? I've got a phone call. I don't know from who. Let's just give me a minute. I hope it's nothing important. Wait, let me. Okay, it's probably nothing important. I can't get back to the people. Okay, anyway, sorry. Yeah. So once you've got that, you are actually the output of your scope of your project definition. You see, I try to use the word here is project definition. Previously, I was using the word scope definition. You see. So here you've got project definition. Then we are trying to define the works. Remember, this is the differences here. You have to be very clear of these processes. Otherwise, you may not, because there's a lot of things to remember. The best way is to understand what is every component, every section that we are learning here, and how do you apply this every component. You see. So like I said, if some project, you may not even need a project charter. You could actually go straight to project planning simply because it's a very, very straightforward, or it's very clear that this is what needs to be done. So we don't really need to go through a project charter component. So then we jump straight to defining scope, your project definitions, and coming up with all the different works that is necessary to complete the project. Then if the project is complete, you actually get your product, you see, what you want as the output of your whole effort, at the end of the day. So output from project definition is a scope statement. And in this scope statement, you will list down things like the objectives, what are the success criteria, what is the scope description. This is also including what you can build. It's almost like you're building your project charter, So here you also describe what is the project, the sizes, the length, the width, the height, and all that. And what is the usage here, and what are the deliverables, meaning what are the components that needs to be seen, deliverables, delivered to the final end user. When you have any testing requirement, what is the acceptance criteria, and then you've got project constraints, what are the limitations on the project teams and the option. Okay, and we've got some of course, we will also do some cost estimation, which is more preliminary. We will also look at the funding limitation, the schedules limitations, and these are not all of this is needed there, but then these are the list of things that you should be covering in your scope statement. So the main thing about your scope statement is justify the project, look at the product, look at the product deliverables, look at the objectives, look at the successful criteria, look at the constraints. And of course, from there, you can look at any where you're going to get your funds from. Is your directors going to raise it from the shareholders, or if you're a listed company, you would actually put it out for fundraising among the stockholders, you know, and then cost estimates, how much would the project cost. These are some of the typical things, and you may want to do your risk management here as well, but I think this is a bit too early for that, like, in a way, huh? So yeah, so we've got some descriptions of what is certain components that we are describing there just now, okay? So you can go through that. I think we went through that last week, actually, right? So then from there, once you've got a really clear idea of the product itself and the works, the components, subcomponents of the product, plus the works that needs to be done, okay? Plus the works that needs to be done during the project, you know, it could be, at this stage, like I said, it's usually the major works. You wouldn't be able to go into some of the very deep layer of a description of the work yet, because many components it hasn't been through a final design detail yet and all that, okay? But you could actually just take down, you know, one of the few major layers, major works that needs to be carried out in order to do the project. And then once the project is complete, you actually get your subcomponents, and your subcomponents, you get your components, and finally your components all add up, it will be your product. Okay, so do you guys understand up until this point the difference between a scope statement and a project charter? Okay, this is just like going more and more in depth in that sense. Okay, so after you already have your scope statement, basically at this point in time, the whole project concept is pretty developed. It's actually pretty good. Like, then the next question is, you need to be able to answer the question, are we proceeding with it or not? Because with a good idea of what this project is all about and the works that goes into the project, you're giving the directors and also the shareholders and also the investors of the project a very good idea of what is going to be involved, you see. So, and then they need to decide whether this is going to be part of your organization mission and vision. Is this your organization objectives? Is this going to be part of your organization aim or the setup for the future? You see, so it is very important for them to say a yes. So we went through what we call a project screening and selection. And this point in time, it is really about screening between ideas with ideas, project with project. Okay, we mentioned this last week. So you can create your own evaluation model. And this evaluation model, like I said, if you're working for a private company, you're working for a government agency or non-profit sectors, your evaluation model of whether you really need this project or not, that is one question. Number two is maybe it is a necessity. If it's a necessity, basically it's a goal. You know, like there's no choice, you have to go. It's just like government, a lot of the work are necessity. For non-profit organization with limited funding to them, they would really have to go for what is necessary. For private, obviously, it's about who is going to make more money for me. You know, which project is going to make more money for me? Which project is going to bring us to the next level? Which project is going to make us more famous? You know, and which project is it going to make our company more well-known? You know, and then later on get more bigger projects elsewhere. You know, and yeah, I mean, like there's many reasons why companies or why organization actually would actually, you know, pass a proposal basically. So the scope statement, it is a new proposal. So went through some screening model, and in the screening model, like I said, different organizations for different purposes, they have different screening mostly like on the bottom line, it will be a few things that is dealing with money. Okay, do we have the fund to build it? Do we have the fund to carry it out? That is one very important screening model. Maybe your project idea is so huge, the dollars and cents, the budget is so huge that, you know, the company will say, can I read it? You know, these are some of the basic questions. And then some of the companies will be asking how much it costs and how much will I make at the end of the day? What is a percentage of return on this particular investment, on this particular effort that we are putting in? You know, maybe it's better for me to put my money, you know, in stock market, or put it in trust funds, or put it in even the banks. You know, that, you know, if just this project is going to make me 2 or 3%, I might as well just let it sit in the bank, and, you know, it's a lot more safer, lot less effort, you know, and yeah, all that. So the screening model itself, like I said, it will be social economics, you know, so for a lot of government project, it'll be social economic, legal, political, you know, that sort of things, you know. And private, obviously, we're talking about businesses, goodwills, yeah, optimization of the company's resources, and making to be staying in business, to make whether it meets the long-term or short-term organization goals, you know, and all that, and or whether your company is actually looking to diversify their businesses, and this may be one of the projects that will really bring you next step to diversifying. So for non-political organization, like I said, it's solely dependent on their own needs. Usually it's needs, whether they need it or not. It's just like I say, school for the mentally retarded children, you know, there may be a need to create a new room, exercise room for the children, and that could be a need. You know, it's not about whether you have enough money, or whether what is the benefit and all that, but it's really a need. You must have it, you know, otherwise the children is going to be not doing enough of muscles exercise, and they may have problems later on, you see. And that is what we call a need, you see. Yeah, so then because it's a need, the screening, the project is yes, and then you need to go and find money, you know, you need to go and get donation, get charities, you know, doing charity sales and all that, or get people to donate, or make items to sell in order to do this project, you see. So for non-profit organization, it's usually driven by their needs, okay? So once we've got this initial screening, like I said, most of the rules here are, yeah, it's about economically viable, it's about whether it's possible, technically, whether it's possible. There's another very big question you have to answer as well at this stage. You cannot, you cannot have an idea that maybe at this point in time, your land is not suitable, your location proposed is not suitable, or technically it is not viable. You know, you want to build a bridge, but that location, you know, the ground condition or the river flow, the hydrological direction of the flow of river is not possible to build it there, you see. So we could have issues like that, you know, like when you want to build raw water intake plant, you must have enough of water to be pumped out, you know. So if that location are always permanently dry, that is not possible. So technically, whether it's possible, financially, whether it's is actually viable, and economically, whether it's feasible in that sense, right? So I think I should use the word feasible, not I like to separate feasibilities and viability, so it's less confusing for everybody. And this is the part that we talk about, you know, what sort of studies that we do. You see, when we are answering whether are we going to do a yes or no selection, you're looking at opportunity studies or feasibility studies. These kind of studies will usually cost about, you know, 0.2 to about 1%. And pre-feasibility studies is about filtering out those alternatives that is not possible at all. Then we are looking at, we'll be doing this at this stage, this initial screening stage. And this sort of studies normally will cost about this sort of price, this sort of money, you know, to be carried out. And then with this Feasibility studies is later on when we're doing option studies, then we do feasibility studies. But here, opportunity studies and pre-feasibility studies are mainly about a yes or no. The important thing is yes or no. Are we doing the project? We're still answering this question here. And these are the things that we have to go through to answer. And you may be asked to do a presentation to your bosses and all that, to convince them what is the best. I mean, this is really the best thing that the company should embark onto, and hopefully you get go ahead from them. So screening and selection, the selection model, like I said, these are some of the model. I mean, these are some of the, like I say, this is a bit like a sample, sample that you can have. You can create rubrics and fit. Main thing is always in this stage is like, do you have your organization have the strength to do it? What about the weakness? And what about that sometimes this project may be really good, but it just so happens that your company don't have that kind of resources, or you are naturally weak in those areas, so you may want to you cannot embark onto it after you've done your evaluation. So this evaluation criteria, you can have things like this, a scorecard for all the ideas. Obviously, I think most of the bosses will they already kind of know what they want in that sense, and some of the ideas may be so, so amazing, they cannot say no. Nobody really sit down with this sort of scorecards. But honestly speaking, because as company gets larger and larger, and also even government organization, non-profit organization, a lot of things are requiring us engineers and also the whole corporation to actually have proper documentation. And you need to really sit down and do proper documentation, so that later on when there is audits, or whether there's a taxation audits, or whether it's a company internal audits, like for example, in education here, we have a lot of different kind of audits to see our syllabuses and all that. So we need to prepare a lot of these scorecards and all that to make sure that whatever decision that we make, it is not no conflict of interest, it's no personal level kind of thing, it's no like I want it, I'm a politician, I want it, or it is just my own agenda sort of thing. So you need to really have basis, and you need to have a proof of your thoughts, and prove that, especially for like listed company, you really need to have these sort of things. You cannot just say that, oh, the board say yes, or the board of directors voted yes, and then that's it, there must be a reasoning behind their voting and all that. Yeah, so it's very important to do that. Yeah. And yeah, so you need to consider, your project with different criteria, whether it's realistic, whether you have the capacity to do it or not, whether, as you go along, you still can modify and make it flexible, the cost wise and ease of use, like whether this particular project is going to be really bringing benefit and all that. Okay, so these are some of the techniques that is available, and normally we are concentrating on this particular thing. So these things here, Dr. Lee will be covering with you as a whole. We talk about this as engineering economics. So you're gonna have a whole class next week on engineering economics. So please bring your brains with you to the class, and don't just sit here, and with your soul somewhere else, or with your mind somewhere else, or you put it on and then you go somewhere else and drink coffee, or pick up your kids and all that. Don't do that, because when you come to calculation, it's much better that you sit down and you listen and go through the calculations, the formulas and the examples and all that with the lecturers. So Dr. Lee will go through that with you next week on engineering economics. So once at the end of this, what we are looking at is to make sure that we have a project that is a yes, we're going ahead with it. And then there is always an option that is called do nothing. So at the earlier stage when you're doing project screening, you could just say that do nothing, don't do it, don't embark onto it. So yes or no is yes is go ahead, no is do nothing, don't do anything. So once it's a go ahead already, it's very natural for client to want to know what sort of options they have. You will hear questions like, can you add this thing here? Or do you think you can make it bigger with the money that I have? Or with the budget that we have? Or do you think you can cut down on certain components? Is it really necessary to have this, this particular room, or to have this particular components, or to have this particular sections? It's just like you're building a computer, or you're building a laptop, or you're building a phone, yeah, a product. Some of these things are maybe not even necessary, to be there, but they're taking up a lot of costs, you see. So do you really need it? Are we putting our money at all the right places? Are we developing an idea that, most users will find it very, very easy to use, and they will come back, and they will come back for more? It's just like our kitchen appliances nowadays. My washing machine, for example, it's got like 4 different selection of items, 4 different selections of items in terms of normal, and then you've got super clean, and then you've got this extra large, and then under these 4 different options, you've got another 4 different options. So you've got 16 different options. And then guess what? I always press normal, normal loading, normal clothing, You rarely even go and explore like the super clean or super delicate or super sensitive or baby or whatever. Yeah, if you have baby, maybe you press baby, you see, but no, like we hardly use that. So then you're going to develop a machine, you're going to spend R&D into all these sort of like 14 different functions, 16 different functions, and the money that goes into it. But at the end of the day, the users are really just going to be using like me, I'll be using normal or 1 or 2 of the other 2 options. So is it really worth it to buy something so expensive as end users? Do I really want to, putting so much money when I'm just going to be using normal all the time? You see, yeah, like some people, you don't really use your phone to draw, art and all that. You just use it to do WhatsApp, WeChat, and go online to watch YouTube, and maybe download your assignments, and work file, and that's it, But then your phone is super high tech, to a point that you honestly did not use some of the functions. So it's the same thing. So organization, do you really want to have so many components that you're not necessarily, it is important. It is money to develop them, you see. And then when you develop them and they cost you money to develop, but you don't actually use it at the end of the day. Same concept, huh? So this project scope, at this point in time, we're putting it through tests, and this is really engineering economics. Tests of engineering economics are normally, I would say, but I wouldn't completely say it's engineering economics. So we should really look into many, many components here. Like, yeah, I think we solved this last week. Time, cost, quality is here, okay, and scope is here, okay, and yeah. So at this layer, we are looking at options versus options. So different options will have different costs, and different options will have different benefits. So in order to do a cost-benefit analysis, you could do it with a dollars and cents cost-benefit analysis, or you can do it with a qualitative way of looking at social, looking at lifestyles, looking at quality of life, and legal and law. All these things are under more qualitative kind of cost and benefit. So you could have a very straightforward dollars and cents study on cost and benefit, or you could have a very qualitative way of studying cost and benefit with maybe as much as possible trying to quantify them, but they cannot be quantified in dollars and cents. But you could probably quantify like heritage and culture with goodwill, with the company's good name and all that. Those are things that are not being able to specifically quantify with dollars and cents, but you could actually have certain rubrics or certain way to quantify them using certain uniques or certain numbers, that is other than monetary terms, in that sense. It could be numbers of cases, or it could be things on the general health of the public, on hospitalization, on data, on statistics, so these are the different ways of looking at cost and benefit. And you could, like, for example, building a road, could it be time savings? Could it be car maintenance? Could it be the avoidance of traffic jams, the comfort of driving. So these sort of things, depending, some of this is actually quantifiable in terms of dollars and cents, some of it is completely not quantifiable, but you can quantify it in different type of units. So the difference between non-quantifiable and, cost benefit in terms of quantifiable, we always call it CBA, and those that is unquantifiable, more qualitative, or you can quantify it with other units are called effectiveness analysis. And then of course we will do an assessments on, we do a financial evaluation also on things like whether it's going to make return, the return is good or not, the percentage of return is good on the depreciation, the profit. These are all on financial evaluation. Okay. Economic side is different from finance. Economics is more on, benefits that is actually quantifiable in dollars and cents. But financial evaluation is mainly about whether this project is going to make money or not, whether it's going to return the money in the shortest possible time or not, and whether you have the funding for it or not, whether this is financially viable or not. These are financial evaluation, or you have the cash flow for it or not. So these are financial evaluation. It's very different from, it's actually different, okay, not very different, it's actually different from economics, even though economics also deals with dollars and cents, but they're looking at a different benefit that can be quantifiable in dollars and cents, okay? Are we still okay? Are you guys okay yet? Still okay, huh? Still understand? Still following? Are you following? Okay. All right. And here we will be generically calling this as a feasibility study. So when you're having these options with options, within the options with option, you're looking at the technical, you're looking at economics, you're looking at social, you're looking at finance, all these lump up together. Most of us will call this a financial feasibility studies, whether the project will, which options is actually better in that sense. We're not answering, because this at this point in time is about options versus options. There's no more things like yes or no anymore. It's just which options is the best. Are we going to build 2 lanes? Are we going to build 4 lanes? Are we going to build a cable stay bridge, or are we going to build maybe a box girdle bridge, etc., etc. Are we going to build a three lane flyovers, or are we going to build a 4 lanes flyover? So all this can have you need to study this, not only in terms of social economics, technically also very important. You need to collect things like topography, you need to collect things like bore logs, you need to look into some of the river water quality, you need to look at the river flow, you need to look at the hydrological flow of the river or the ocean, for oil and gas people doing platform, you need to look at the ocean profiles, and wave profiles and all that. These are very important studies, or that needs to be done as early as possible to compare the options with options, okay? So if you because the location of the site will not really change unless your options is about location versus location, then there's another different level of studies. I mean, there will be technically studies, they will be a bit different, but if let's say it's just about the components, like changing the components as an alternative, then you are looking at still the same site. So a lot of the site studies is already there, so for the same options, for different options, for option A, B, C, it's the same site. So some of the ground conditions and all that, you probably don't need to talk about it anymore. Like it's already there, you can't change anything. All right. So please remember, when you're studying your cost and benefit, you need to also study your technical studies. Need to look at whether your alternative, your options are actually technically viable. Some options may not, it can bring you good benefit, you have the money to do it, but technically at this point in time, you may not have the ability to design or build this sort of level of things, and then you may end up having to pay a lot more to get expert from Singapore or from you know, from UK or from Australia, you know, to come in and help, and that is really going to be quite a lot of money involved. So technically, it's also a very important studies that needs to be going on at this point in time. So, but those sort of data are usually preliminary data, preliminary technical data. So yeah, we describe what is cost effectiveness analysis, cost benefit, cost effectiveness analysis. So we are looking at value. So main thing is when you vet options versus options, you're looking at benefit, cost, value. Okay, these are the three things that you are really looking at to study in that sense during these options versus option studies. So feasibility studies, I just give you a section here on feasibility studies. What are the components of the feasibility studies? What are the main phases of feasibility studies? And what do you do? What is it good for? You know, please read through this. I mean, it is important. Sometimes we in exam we may have a very simple give away marks kind of questions that you can actually just ask. What is the major functions of a feasibility studies? These are the places that we will be looking at to answer those questions. Yeah, it's just very general terms. Definitions are feasibility may say to be defined a project before it's implemented. For the purpose of this module, we will say that is the study may assess whether the proposed project is capable of design solution which is practically, economically, socially, and environmentally viable in terms of the client group's perceived needs, restraint such as capital, future operational costs. Okay, so this is the purpose of feasibility studies. It can be as big as option studies. It can also be just a very important technical studies, can also be feasibility studies. It can be a very big social economics and all that kind of studies as well. So again, whatever we mention here, it is the foundation is about whether the options are actually valued in that sense, has good value, has benefit that is a lot more than the cost, and what are the costs and can you pay for the cost? Okay, so these are the foundation of studies, of feasibility studies. But like I said, from industry to industry, you could actually call it differently, you know, or you could actually have slight difference in the content of it. Some of the feasibility studies may be very, very technical, like you call it preliminary investigations, maybe, or site investigations or site studies, you know, that could be it. And then some people can actually, because some of the options, I mean, some of this project is like, you don't necessarily have to study the economics or the social and all that, you see. Not necessarily. Like for private project, mostly we're looking at financial, you know, like whether you're going to make money, the return and all that. So you may not need to study so in depth into the other parts like economic, social and all that, you know. So yeah, it really depends. It really depends on what kind of project that you have or what kind of product that you're looking to carry to build, you know, to accomplish at the end of the day. So I don't want to limit everybody to say that, you know, this is it, you must follow every single part of it. So it's up to you. I mean, it's up to the project itself. And then as practicing engineers, I'm sure you all have a good idea of what is necessary and what is not, you see. Yeah. And yeah, so main phases is data collection. You normally would need to collect a lot of historical data, forecast data, okay? And yeah, and then the data, some of it is known one, some of it is something that is really not certain, you know, and then you need to look at market demand, economic trends, authority approval. Then when you collect all this data, technical data also involved here, and then you do the analysis, okay? So analysis can be from different perspectives. Analysis is very, very much done from, number one is the problem solving, where number two is a technical, number three, you know, like on this sort of sequence, normally we will do the analysis, okay? And then of course, at this point in time, we will do risk assessments as well. Okay, then we will come up with the feasibility statement, whether we are going to proceed with the particular selected options, okay? So contents of a feasibility studies, yeah, we have technical studies, we have economic studies, okay, economic impact. We will also have social, yeah, social studies, okay, social studies, different social studies. And we also have environmental impact, okay, environmental impact, yeah. So these are the few things that we would normally look at, quite majorly some of the few things that we look at are technical, social, economics, finance, and also environmental studies. It's getting more and more popular, more and more hot to actually consider more of, on the environmental impact of the site of the long-term effect of our project and whether it affects any things on conservations and on certain weather, pollution, these sort of things are actually pretty much also part of the studies that we need to carry out. Okay. Feasibilities versus viability. I think we've mentioned that. Feasibility studies really seek the answer of, is it possible? Okay. And like I said, in the feasibility studies, you determine what are the options, what are you need to gather on the demands, on the data and all that. And whereby financial studies, you are most likely to be looking at how to obtain the finances, and how to make your client to go ahead with the project, or are they going to invest or not invest, or whether they will not invest first fully, but they actually rent particular facilities. So they don't really have to all the time go for purchase, you see. So that could also be an option for them, and whether they need to have investors or joint venture partners, whether they are whether this sort of are they going to collect any money from it? Are they going to make any good justifications on the expenditure of the company's money, and whether the return will be good, acceptable at an acceptable level, yeah, and then whether they have marketing to support it. So these are the issues that we'll be looking at when we talk about finance, you see. So financial analysis, we also mentioned here. What is financial analysis? We talked through, like I say, mainly it's about the identification, about development, selection, control. These are the money part of the whole project that we are looking at. Cash flow, very important. Do you have the cash flow to carry out the particular project at that particular period? It may be a fantastic project, but you don't have the cash flow to do it at that particular point in time. It's also a big issue as well. And like government, do you have the funding for it? For certain projects, like is the federal going to give money? Some projects, like maybe the state will not have money, and then you have to wait and wait and wait until federal, which is the national level government, to give you money. So it's not going to be from the state or from the district or from the councils, So project funding can be from many areas. So we need to know where the funding comes from. Do we have the cash flow to do that? Cash flow meaning cash flow will be how is the money flowing in? I mean, how is the money going to be flowing out? Do you have enough of money to flow out at a certain period of time, and then the money will be flowing back after you sell your products, or you collect rental, or you collect fees, or you collect tax revenues and all that from the particular facilities, then there will be money coming in, you see. So this cash flow is, you need to know whether there is enough money for you to tie through times that you are low on cash flow. So a company cash flow is so important. Some people go bankrupt because the cash flows are not doing well. Because not to say that the project are not making money, the project is actually making money, but the money that is supposed to come in is so much later, and they don't have enough of security bank. I mean, they don't have enough of backup to actually pay for a lot of things first before the revenue actually comes in. So you need to know whether you have that kind of cash flow or not, you see, before any sales cash flow return that comes in. So your company must be strong in terms of the cash flow. Funding is mainly on the project workflow, whether the project is, the funding is really on like the sources of funding, where you're going to get your money from, whether it's going to be raising from your shareholder is pumping in more money, or one or two of shareholders is pumping in more money, and that may change the company shareholder shareholding percentage. And is that important? Like maybe it's already 50-49, then how, if this guy's going to pump in more money, he will get more percentage, and that could be an issue with the organization set up as well. So project funding is something that we really need to look at as well, and whether you're going to have, are you going to borrow money from the banks? Are you going to be borrowing monies from some of the government agencies, or is there any sponsors from because it's a special program, there will be sponsor for finance, special banks that will give you certain packages, financing packages due to set up like that development project. I'm pretty sure from country to country, for Malaysia, our development projects are actually being paid very differently. You've got scheduled payments and all that, but that may not be happening with some countries as well. So some countries like Australia, as a developer, they only collect as a house buyer, you are actually only paying 10% as a deposit, and then 90% of the money has to come from the developer to finish constructing the whole entire thing, and then pass it over to the owner. Then the owner has to pay the rest of the 90%. So if we talk about projects like this in Australia, compared to in Malaysia at the moment, we have a scheduled funding, meaning that after you build the foundation, you get the developer get to be paid 10%. After you build first floor, they get to be paid 20%. After the finished architectural work, they get to be paid 20%. After the roof comes out, they will be paid another 10%. So you see the fundings are quite consistent for their project. But if you're in Australia, you only get 10% of the money from your buyers, and then the rest of the money will only come in at the end of the project. So if you're not a cash-rich developers, you really don't have, you really need to raise your funding from other places. Otherwise, you may kill the whole company's cash flow. Okay, and then also this part here, when we talk about finance, we need to think about one very important thing, and that is life cycle costing. Whether the project is worth it or not, whether the product is actually going to give you enough of benefit over a long period of time. And life cycle costing is a very important exercise because it forces engineers to deal not only with up to commissioning. You need to know machines need to be maintained, operated, and then recycled, or it needs to be withdrawn later, or it needs to be disposed later. Same goes with facilities as well. You don't want to be, as engineers, our concentration, our focus when we compare options with options, or when we compare, or when the project is a go ahead or not, when we want to study the finance bit or not, we always remember the capital contribution, meaning that we remember to pay for, we remember to pay for the construction costs, but we forgot that later on the owner needs to do maintenance, operation, and all that. And then that is a part of the costs that are usually not being calculated properly. And that in itself could be very, very harmful, because some project you launch now, it may look good, but in just 5 years' time, you'll be pumping in a lot of money for operation and maintenance, and that could be an issue. I'm pretty sure people are doing hospital maintenance and all that. I think you all have a good idea on all these costs, that the company to do maintenance and operation has to be in there consistently, and that is a part of the money that you need to, as the owner of the project, as a final end users, you are going to be paying for all these later on costs that is going to be over 20, 30, 40, even 50 years before the project is being disposed or recycled or being rehabilitated or being refurbished to be into something else or renovated, you see. I think most of the project, especially in Malaysia, I think we're looking at only about maybe 10 to 20, 15 to 20 years. So after that, you know, we would really need to look into rehabilitation or recycling, or to refurbish it, or to renovate or upgrade it, you know, into something else. So yeah, I mean, like, how long will you be using it? And the reason why we do that, if it's a project is not worth it long term, you may want to get your owner to just lease it, meaning that instead of building a new factory, you want to lease it. You know, you can borrow the facilities, you know, instead of constructing everything from ground zero. So these lease and buy options, always remember that when it comes to money, there will always be a leasing option. So there will not be so much of capital involvement immediately. You know, like for example, people doing manufacturing, you may actually want to lease your machines, you know, instead of purchasing it millions and millions of dollars. Like for example, construction, we may want to lease, you know, we don't want to go and buy an excavator for our project. We don't want to go and buy a mobile crane for our project. We can do leasing, and that leasing can actually saves you some operation and maintenance kind of money at that period. So it may be cheaper to do that, but the leasing is the initial money to lease is actually quite a lot of money, huh? So you have to balance it out, huh? Because construction, you only pay for things as you go along, huh? But leasing, you know, immediately you may need to pay for upfront a deposit fees and all that. That could be a sum of money there. So it really depends on the financial status of the company, and that will actually develop. You know, the main thing is to develop a financial plan in that sense, huh? Okay, any questions so far? Good. Okay. All right, if good, then let's take a short break. Let's take a short 10 minutes break, okay? Because we've already finished one segments of my slides, then we'll move on to the third segments. That is on work breakdown structure and scope control. That one I think will take us another hour or less than an hour. Then we will move on to discuss on your project, whether you have anything to show me on your project, like your options for your projects, yeah? That's what I will do. Like life cycle costing, I will actually have a specific, I will have a specific pre-recorded lecture to explain on how to do life cycle costing. Just an idea of how to explain, just the idea of how to do life cycle costing now. And yeah, so from there, from there you have to from there you get a better idea of how to carry out life cycle costing. But at least you know that, you know, life cycle costing calculation is usually at this point project scope planning part of the project. After the options is being developed, then, or even during the options are being developed or selection of options, you can do your life cycle costing, or you can actually do it like after you already narrow down to that particular options, and you want to study whether the operation and maintenance cost will be too high for this particular type of project, and then you may want to still see what to do or what you can do about it, you know, before you actually embark onto a full detailed design or the full execution of the project. Okay, so we'll have pre-recorded lectures on that, which I will be posting next week for you all, yeah. Okay, so we go for a short break. We'll come back in about 12:50 like that. Are we back already, everybody? Are we here already? 2 likes. Okay. Yep, let's get started and we try to finish early, okay? Yeah, because I'll be posting on pre-recorded also, so there will be quite a fair bit of things to go through for you this week. Right, so now that, you know, we have went through all this sort of, we went through all, you know, from project charter, from definition of the components, you know, to definition of, oh, my nose, from definition of components to definition of the works itself, and to selection of the project, to screening the project, whether it is feasible, whether it's financially viable. And at this point in time, we pretty much would say that we are done. You know, like we are done. We have already defined our scope of work. Then, I mean, sorry, we've already completely developed our ideas. And now the last stage here is just to define properly, you know, as much detail as we can. And this will usually tie in with even final detail design or with some form of designing, with some form of calculation of the work component. So this is what we call work breakdown structure. I mean, for those of you who have seen from my undergraduate classes, you have heard of this before. I'm always a very I'm always very serious when it comes to work breakdown structure. I'm not sure whether your universities actually do it with you in the same kind of level, but for me, we need to put attention on work breakdown structure. So after the project's been studied, feasibilities, everything, so now it's a go ahead, you know, that it's a go ahead. But obviously, if you look at the project life cycle, we are also still looking at, you know, we still need to collect more technical data, more site data, more things on locality, on the ground conditions, you know, on the where you're going to build your production line or factories or all that. So that sort of thing still needs to be, there's still a form of data collection, because now your idea is fixed already. You're fixed on one idea. The works that you are going to do is pretty much there already. So it's about what are the follow up detail. We are going into work breakdown structure is like going into detailing. You see, project charter starting from a study of scope initiation, you get project charter. In project charter, you get the product components. Then from the product component, you further develop it into project planning. Scope planning. And scope planning, you're developing a scope statement. And that scope statement is already listing down on some part of your works, you know, some of the major parts of your work that needs to be carried out in order to deliver the project charter. So in that scope statement, we are going to further study, you know, into different options and all that, and then into yes or no into different options, and from the yes or no and different options and a lot of feasibility studies, viability studies, we've done that. You know, we've done your engineering economics, so you know this project is very fixed. So from this, another last result here is to go into detailing. So you can see from one phase to another phase, your project scope of work starts to get more and more detailed. It goes to more and more detail. And when it comes to work breakdown structure here, this usually will tie in together with the actual go ahead of the project, with the actual designer team coming in, with the actual people sitting down doing designs and all that. And the final designs is going to be out, and you will be looking at filling up all sorts of detail as much as possible. So the scope of the total work will be defined. So the component parts of the scope, you know, the interfaces with each other and all that will have to be all defined here in what we call a breakdown structure. So for civil, we do a lot of work breakdown, which is the work itself. But like I said, some other industry, you may want to do components breakdown again, okay, or interfaces breakdown. We can even have that, okay, and Yeah, I mean, we've gone through that just now in the other notes. So, you know, if IT, then they have other things, you know, the breakdown is different, you know, they call it differently. So I'm not sure about, I don't know, people who are in manufacturing, you know, like or is it processes breakdown? I mean, like maybe for Amira, you're doing a bit of processes breakdown rather than work breakdown. I mean, like it could be processes breakdown. So you've got different processes. From different processes, you have different steps that you need to carry out. So those are processes breakdown. So yeah, I mean, we've got different industry. You are breaking down your scope of work differently. Yeah, you understand? Yeah. Some of the industry, maybe you are breaking down your components of the product. Some industry, you're breaking down the components of your interfaces. For us, I mean, for civil, it's just very straightforward. The work, the activities, the task that needs to be done, we need to break it down. Okay. So this is the purpose, the why we need to do product processes, you know, breakdown. So we really define all the work elements. We relate the work element to one another, and then to the end product, to the components of the products, to the end product. Then it will form project planning. Okay, it will help you with the design as well. So meaning that you know which part to design. So if we say drainage, we need to know we need to design drain. If my scope of work has sewerage, I need to design sewerage. If my road component have road work, I need to design road work. If I have pavement, I need to design pavement. You know, if I have structure, I need to design structure. So technically, for a work breakdown, it will help you to define your technical components as well, like the work that needs to be done technically, and then overall scope of work. So you plan your work, you plan your activities, you plan your components properly, and then from there, work breakdown is going to be so important for you to do resources planning, for you to do your time planning, which is what we're going to cover for the entire assignment, from the assignment all the way to your group project. We're going to be covering all these things. So from now, work breakdown. After this week, you go back, you can do your work breakdown. So when you see Dr. Lee next week, she will be talking to you on engineering economics. But the following week, you have to complete your work breakdown. I will ask her to look at your work breakdown as well. And then you take a look at your work breakdown. If your work breakdown is okay already, the following week, she'll be telling you how to do resources attachment. So with this resources attachment, you are going to be planning for your resources based on your work breakdown. So this is work breakdown is like you can do a lot of things with it actually. So once the work breakdown is, the resources is attached to it, you can start to work on your time. And then finally, when I come back to you on the cost, you will be, I'll be going through the final part of your project already. Dr. Lee will be setting an assignment that is on resources and time scheduling. I will be doing more on cost part. So all of these are the background, all the background. So the first is work breakdown. Then from there, resources. From resources onwards, it will be time and cost. So all the plans needs to come out. Okay. Even later on, the procurement plan, you know, the tendering, the procurement, the designs, you know, all these things are actually based on this work breakdown. Okay. So you may ask, do I do work breakdown first before I do design, or do I do design first or work breakdown? Well, you do work breakdown first, and you break down the work as much as you can, then you do design, because then you know exactly which component of works that you need to design for. So after you do design, you come back to your work breakdown, you see if there's anything you miss out, and you still have to input that in, because later on work breakdown will be more for time and cost and quality, and it's more for project management already. Okay, so it also provides a direction for your project. It also provides control because it allows the work to be looked at from a very manageable components, like one by one smaller component, you know, to ensure that some works are not forgotten. And then you need to look at the interfaces. You can easily look at the interfaces between interdependency or the parallel activity between one component to the other components as well. And then you will be allocating your responsibilities to different group of people to, and then you can even do risk management with your work breakdown structure. Okay, so basically, project is defined with work breakdown structure. I'm showing you some of the different type of work breakdown. So you can have a product breakdown, which is what I mean just now. After project charter, you will have, this is a bridge. The bridge have what? Component A, B, C, D. This is a stadium. Stadium has component A, B, C. This is a product breakdown. So let's say if this is a IT systems, then this is component A, B, C, D. And then if this is a computer, a laptop, a latest laptop, or latest handphone, iPhone, you know, 15 or 20, I don't know now. So then this is the component of the iPhone. So this is your product. You can have another layer, sub-product, but it's okay, you know, depending on how critical it is to have another layer to describe your product. Then your project charter will be mostly on this sort of things, you see. So then we get an idea of this. These are the things that we are further developing into our work breakdown. So in your work breakdown, the development phase of the project, you're doing scope planning. And in scope planning, we are going to take component A, and then we're going to go into, you know, the work that goes into it. This is a very, very good chart for you to look at, okay? For you to understand the yellow bit are the work. So at scope planning stage, we may only have this, you know, this sort of layer one kind of thing. But now when it comes to this component, after you've done enough of study and plus the design coming in at the same time, you may develop it further. It will come down a lot more. You know, it can come down another 3 layers of work, W-O-R-K-S, work activities. So these are activities. So the yellow bit are the activities. They are not components anymore. So that's why when you do your work breakdown structure, I always tell my students it's very important for you to define your work, not define your product. So whenever you want to list it down, so you see this is the work breakdown. It's about activity, okay? So when you want to put in your work itself, you need to be very specific about the works. The product or the sub-components, you don't make it a layer in your, you don't make it a layer, okay? You understand what I'm trying to say? Let's say components, you know, box girdle is a component. I don't want to see box girdle as one of the layer of work, okay? The actual work that goes into making the box girdle, you can put it as layer 1, 2, 3, 4, okay? Maximum 4. Say if this is a school, you know, the project is a school, the component is school building, classroom buildings, canteen buildings, library buildings, stadium, track field. So you've got a few components. So whether you want to have sub-components or not, maybe yes, maybe no. So now you take the one of the components says classroom building. So this one here, when you put in classroom building, you don't put it as your layer 1. Because if you put it as a layer 1, then you do not have enough of layers later on for you to break down your activity. So we don't count component as one of the layer in your work breakdown. I hope you really get this out, because I've got a lot of students when they do work breakdown later on, they like to put things like construction of the classrooms, construction of the stadium, construction of the field, construction of what? Those are components. And then when they do that, they wasted one whole layer already. And then when they move in and talk about foundation, they become second layer. Actually, foundation should be your first layer of activities. Construction of the foundation should be your second layer. In order to construct the classroom, foundation or substructure should be your first layer. In fact, if the components, if the layering is a lot, I wouldn't even put components, I mean that subcomponent as a layer. You know, I would put it as just a title. Construction of the from substructure, and then you went in and talk about the work, the piling, the driving of the piles, you know, the hacking of the piles. So you go into very specific, okay, very specific activities as your layering. Okay, so this is a very pictorial hierarchy format of your of a work breakdown structure. So you are talking about deliverables, okay? Deliverables, sub-deliverables, huh? The works lah, basically lah, huh? These are more of product, huh? Take note lah. These are more of product, huh? Because when we talk about deliverables, it's components, huh? Major deliverables, major components. So these are more on the product itself. Again, like I said, project management is not only for civil engineering people. There's going to be, you know, for a lot of different group of people. You, depending on what is your product, then you are looking at whether you're doing your project is a product. Then you are looking at something like this as your layering. But if for us, civil engineering, I think most of 60–70% of people here are going to be doing civil engineering project. So you are going to be looking at. Be careful when I go through your work breakdown. I do not want to see components, you know, as your layer. I want to see the actual work as your first layer. Work packages, that is another way of describing your work breakdown. So you can put it as work packages, a substructure works, is it? Or substructure or foundation work, structural work. So then in your structural work, you break your layering down. So you can use work packages kind of method in order to do your work breakdown as well. Okay, and this one is always very closely related to critical path. So when you have work package, use that when we do critical path analysis, we do not want to have many branches. It's very difficult to have many branches. So what we prefer is you have a work package, and in that work package, everything under like substructure, all the work under in there is already broken down into layers, but you lump it down in a node called substructure. And this substructure will take how long, okay, to do. So it's easier to do a work package kind of node and lines for you to do critical path analysis. Critical path is one method of scheduling to look at the activity, the task, how long it will take, the earliest start, earliest finish, the latest start, latest finish, and you will be looking at which one among all the packages, which are the critical work that has to be done without causing any delays to the project, and it will help you with resources refining as well. Instead of it will help you with resources refining, meaning that you design work breakdown, you attach resources. That is what you need, but in fact, most of us will be dealing with multiple projects at the same time, so you do not have all the resources to deal with one type of project, one project you have in hands. So you may need to share your resources with other resources. So through studies like CPM, critical path methods, analysis, you could actually do multiple projects, share your resources by looking at the time lapse between one activity to the other activity, meaning that some activity you can delay it without delaying the whole project, or some activities you can delay it without delaying the next activity, so you can lend your resources to another project. So this is about resources refining. So then you do not have all the resources that you need, so you need to go back after you've done your scheduling. You need to go back and redefine some of your resources. So we call it resources redefining now. And yeah, so and if you in work breakdown, if you do the work package method, these are what we will generally use for critical path analysis. So like I said, you have you lump it under what we call a structure, you know, or under drainage work, under water works, or if you have raw water intake tanks, so it will be the raw water intake tank as one work package. And raw water intake tank will not be as one work package. Sorry. I mean, I shouldn't be saying that. I'm actually slapping my own face. So raw water intake tank, the pipeline, and then the treatment plant, the supply and distribution, those are your components. So this is your product components. So when you come to work package for the raw water treatment plant, it will be foundation work, it will be the M&E work, it will be the structural work, it will be the what is piping work. Okay, so then these are your actual work component. So in that work component of piping work, what are all the sub activities or your sub activities under piping work? Okay, and then you take that as your work package. Structural work, concreting, form working, doing your bar bending, pouring of concrete, those are your work package, the activities, smaller activities or sub-activities, tasks and subtasks under the work package for, under the work package of structure for, what is that work package structure for? It's under raw water intake tank, raw water intake, for example. Okay, yeah, so we split up. You have to get this right. I mean, like later on in assignments, we've got to get it right, you know, and then in exam questions later, you've got to get it right as well. Because sometimes a lot of students, they do not really fully understand the definition of the components. And then when the question asks you, describe work package, for example, and then you end up, you know, talking, you end up couldn't understand the work package, you know, or product or project or activities or sub activities. Those keywords are very important. If you can't catch those keywords, then you'll be answering it in a very, very funny, you know, out of the topic kind of ways. And we cannot, you can tell me, Dr. Ting, how come I fail? You know, like how come I fail? You know, I wrote so much, you know, I wrote 3 pages. But the thing is, I'm sorry, you're not writing on the right thing. You're not describing on the right thing. So that's why you see me getting so worked out on trying to explain to you, you know, between, you know, again and again repeating the word like works, you know, project charter with scope statement. There's a two. One is about works, one is about product components, you see. And then now work breakdown, we have product, project. Project is about activities, and activities we can have work packages. Work packages is maybe you imagine notes, you know, I will show it to you later how it looks like. I mean, for people who have never done CPM before, I think I can show it to you. You know, under that note, sir, we will need, that is one work package, okay? Wait, it's not here. This is the ADM, PDM method. So you see, network method. So when we talk about work packages, for if we analyze CPM, we do not want to have a lot of small activities. The smaller activities you have, then you have a very, very complicated network. So what happens is under each of the package, you know, under each of the node here, we want to have one work package. And under one work package, there is activities and sub-activities or even sub-activities. So it can be many things combining in that one work package. You understand? Huh? So these are the reason why I emphasize on work package is mainly for this sort of like node analysis purpose when we have packages or we use the word packages, okay? But it's the same thing. It's like taking part of your work breakdown structure and make it into describing it differently, like in that sense. Let me see if there's any other examples that I can show you. Okay, like for example, this is work breakdown. Okay, this is your work breakdown structure. This is your work breakdown structure when you have level 1, level 2, level 3, level 4. You can see that here when we talk about foundation work, this is already activities. If there is a lot of activities after that, this foundation work, you can treat it like a sub-components to your project, to your product. Like I said, your product will usually have product, components, sub-components. So we do not want to use components. But if sub-components work is already quite important to be defined, then you put the construction of the foundation work. So inside the foundation work, I will have piling and pile cap as my second layer. And then my piling, delivery of piles, preparation. So these are the work that you combine together to make piling works, you see. And if there's anything that needs to describe the driving of piles or joining of piles, I need to put in here, extra, you know, extra wordings here, second layer, fourth layer. But normally we don't want to go more than fourth layer. In fact, 3 will be very nice. And I'm pretty sure for polymers people, manufacturing people, 3 layers is going to be more than enough for you to go about describing the project activities already. Yeah, so that's why I say you have to be very stingy. You have to be very stingy with your components. And if the project is very, very small, obviously you can have the sub-components in there as well, okay? Like there's really not much things to describe, then you can put in the sub-components here as your level 1. So this is how we typically would draw our, you see the one that I show you is just overall hierarchy format. These are the layering format. Okay, these are the layering format. These are the level format. One level, one level, one level. I'm sorry, this is a level, this is a layer, okay? So you can write your work breakdown like this, or you can write your work breakdown like this. It's fine. So whenever you do your assignment, when you say, okay, below are my work breakdown structure, you can start off by drawing something like this. You can do this if you want, but I think for me, especially as civil engineer, these are not practical. This is only practical for people in mechanical manufacturing, because your activities or your processes are not so much, you see. For us, our activities is a lot. If I use this sort of method to draw, honestly, I tell you, I think I take one A3 paper, I need to stick a few A3 paper together later on. So it's going to look awful, isn't it? Yeah, I mean, we don't want that. Or we can have to print it on one A1 size. It's not practical to use hierarchy format, but hierarchy format is very easy to read. If let's say your processes, like for people in manufacturing, your processes are actually design, fabrication, assemble, then under assemble, there's only a few more, then it can be shown in a nice, if you can show it in one A3 paper, I mean, that's fine. But please don't break your work breakdown in this hierarchy format into 3-4 sheets of A3 paper. That is too much. One A3 paper, you can fold in your report to become an A4 looking paper. That's fine. That is good enough to use hierarchy format. So, but for us, we will generally, you know, for several people, our activities are a lot, you know, can be like hundreds sometimes, you know, 50, 60, hundreds of them. So we need to actually use this sort of level format. So you make it into different columns, or you can do it in the layering format. This is 1 layer, 2 layer. And layering format, we will always go by some sort of numberings or some form of color coding. You can also do color coding here to make things look nicer, better, and easy to recognize. You can also do that, okay? So then, once I draw my, once I want to study my, this is good. This tool is very good, easy when you want to draw your schedule later. Okay, very easy. Your schedule can be out, like presented with this 2 column, you know, or the 5th column onwards, you can start to draw your schedule. So it's a good presentation for your schedule. But for CPM, you don't want to take all these small activities, you know, and then you draw, you use this as your work package. And then you draw it, oh my gosh, then it's going to be so many branches until you yourself also cannot analyze. And then you analyze and you make mistake. So what we normally do is maybe we will use this level. If there's a lot, like maybe 20, 30, or even 15 to 20 level, we would take this as your work package. And this one work package, a foundation work, all this work under here, under this yellow, is your work package. Building is your work package, because these are the items that goes underneath building. So you can take your building works as a work package. So let's say if your project is only structure, you can take ground beam as a work package. You can take slab as your work package. Okay, or foundation work, earthwork is your major activity, is your major scope of work. Then you can take your level 2 and make it into your work package. No matter what, work package comprises of activities and sub-activities that has to be completed in order to complete that particular work package. It's just a name, you know, foundation work, work package, building work, work package. Okay, so you do that especially for CPM, critical path analysis. Okay, so you've seen different formats basically for work breakdown. Yeah, computer, you know, systems. Again, there is other. Sometimes we use this sort of structure to show you the organization breakdown. Also can. You see, the major deliverables. This is product. Okay, and then you have subcomponents, and then this part here can be made into groups, and activities can be made into your work breakdown structure. Okay. This one is maybe easier for people who are in manufacturing. You can look at something like this for your work breakdown. It's fine. Okay. Work breakdown can also be like this, in that direction, can be coming down like this, can be going through like that, also can. Okay. There's some examples of different type of breakdowns. This is relationship breakdowns between people, between project and people. All right. So once you've done that, like I've mentioned, you can actually do your scheduling. I've already shown you more or less, and then now you can do your project cost estimates as well. Yeah, and then after that you can once this is done, basically once you plan out your scope of work, you're doing a lot of planning work already. You can even do your quality management. You can list down your work breakdown and what are the different specifications or different codes that is required for different works or different work package. You can actually put it down on your Excel files. You can do that with Excel. And let me show you some of the work breakdown I have with some of my other students previously. They have done some good jobs on it. Don't worry, I'll post all these notes as well. Even if it's a side notes, I will also post it up in your in eLib as well, so you don't have to be busy taking photo or something like that, worrying that I wouldn't be putting it in. Let me try to find it. Let me see if it's here. Nah. It's done by some for my Mang students. They have done a good job. I mean, like I picked some of the very good work breakdown that looks really good, you know, with as examples. So I will give you these examples also. So you got different kind of these are all, you can see these are all works. These are all works. You see site boundary survey, lot survey, topography, you know, and then third layer driving of the piles, you know, third layer Bakau piles for water surface, all these things. Okay, so construction of the ground beam, construction of the floor slabs. So this is a good work breakdown. Okay, just to show you how you can do this. This is one example. Not the numbering is up to you. You know, you want to go by A, B, C. Sometimes, you know, some people say A and then A.1, you know, and then A1.1 also can. I mean, there's no harm at all. Okay, and I will give you this one as well. Like, I mean, like how they actually attach resources. This is an example, basically, but we haven't gone. Resources is going to go through by Dr. Lee. Okay, and then so we wouldn't want to make any. I don't want to jump first, these are the steps that we need to do. Later on, you can take, I will show you, I will give you this example for you to actually help to do the different components of your assignment and your project also. You see, so you have your work breakdown. This is the work breakdown. Then from there, you can see that you can calculate the quantity of items required. Then you will have production rate, the production rate for the labor, the machineries. A bit small. I know it's a bit small. Don't worry. You know, this is just to get you an idea what are we using our work breakdown structure for. And this is some of the sample formats that we have. Let me show you other things that's a bit bigger. Let's see. Not here. Wait. Oh, it's here, my project management class. I get very confused myself sometimes. I'm teaching like so many project management topics. Even my undergraduates are actually doing project management this semester with me as well. I've been teaching project management for like, how many years? 20 years maybe. Yeah, going into 20 years. Kind of get sick of. Actually, I'm never sick of project management, you know. I cannot say I'm sick of it. It's just that sometimes I get very confused myself, you know, in terms of I teach who already and I forgot who I teach, you know, kind of thing. So I get sick of myself actually. Sample. Where are you? Here. On it. Okay, so you can see the level. These students, they do a level kind of format. Okay, then they attach material, then they attach machineries with every single one of the with every single one of the activities. So you see, when you attach materials, when you attach machineries, it's on the smallest layer. It's not on the largest layer. So if you only have 3 layers, then you'll be looking at the smallest layer. I mean, the smallest layer. If you have 4th layer, it's everything in the 4th layer, okay, that you need to address. And also, if that particular activities, that particular work package has no 4 layers, then is the attachment here, it will be for the 3rd layer. Okay, so you can see the 3 major resources. Dr. Lee will go through this with you: material, machineries, and manpower. So when we have these 3 M's, you are attaching it with the levels. Okay, you can see this is important things. Why? This give you quantity. These 2 machineries and manpower, when you calculate them, they are time-based. So you need to work on what we call production rate. From the production rate, how much can the machine do in a day? How much the manpower team can do in a day? Then from there, you calculate based on your quantity, you can come up with your time, the duration for the project. See how powerful all these things are? And then here, obviously, you need 5 days of what machines, or sorry, bar cutting bending machine, you need 5 days, and the rate is 450. So you straight away can calculate your cost. So this is what I want to see in your project, my project later. Dr. Lee will want you to calculate all these things later. You will have to work out this table first. of the resources, and then from the resources convert the information into schedule, and then convert the info from the schedule. You take the schedule and you convert that into your cost, because machinery and materials, they are time-based. You know, labor working for you 1 day, how much? Machinery working for you 1 day, how much? 1 month, how much? And material itself, of course, is by the rate. So you've got the quantity, you've got the rate, you can calculate your material. Okay, so you can see this is work breakdown is where it all begins, you know, something like that. And you've got some of my students will break it down this way. It's also fine with the numbering 1, 1.1, okay, 1.1.1. So this one, actually, I don't like it so much because it's supposed to be start off from 1, 1.1, 1.1.1. So this one already, in a way, they went into the 4th layer already, unnecessarily going into the 4th layer. I already tell those students sometimes, you know, like multi-purpose hole. So this cannot be 1 layer. This is just a component for the project. The project is proposed stadium in Surrey in one of our division. So one of the component is actually multi-purpose hole. That's why I get them to delete the number here. So you don't want to put it as a layer. This is only a component. But I think these people, they should have put this as 2, for example. So they delete the numbering here, but they still continue with the smaller numbering. So it makes the thing looks very long. Supposed to be, if they do that, they have no room for number 4 layer. Otherwise, you have 1.8.1.1.1. You know how tedious is that? And how confusing is that? We don't want that, okay? So these are some of the good and bad of work breakdown. Maybe I will need to list it down to you. Some of these samples are the one that, you know, is good or not so good. And this one didn't get really high marks, because of the numbering, not so great. So, but then they did a good job in terms of also doing the distribution, labor, you know, and manpower, you know. So all these, they attach different group of manpower, and then they also have different group as a machine. The machine one, that I think they take it completely differently. Material. I think there's another one on machine as well. They did one on machine as well. So different pages, I mean, different tables for different machines, for machines and material, and also the machine, material, and manpower. So some people like to if you want to do it in one whole sheet, also can. But if you want to split it into different tables, it's also okay. Okay. Then we have another samples here on different type of this. I think some people who works for JKR, you see that this is actually more or less a copy from you know where yeah. So I mean, like, as much as possible, I don't want to see that if you really want to take you get what I mean? A just now, you know, A1, you know, and A1.1, you know, and it gets really confusing to have this sort of coding, you know. So I mean, again, these are not very good examples of what we need to see, you know, from your work breakdown. If you say the numbering, I prefer the one just now. This one is even worse, okay? But then, and this one is a copy from some of the specs that, I mean, the BQ that they see, you see. So, I mean, some students are like that, so you want to risk doing that, that's fine. I mean, it doesn't give you good marks if you just copy from somewhere. And they don't do the proper description. I mean, they don't do their own description of the work as well, okay? Again, this is about attaching resources. You can see that this is material, labor, machinery. So you can do it in one sheet like this. The samples I'm going to give you is there are some good and bad form of if as a sample, they are all not bad. I shouldn't say they are bad. It's just that not so great. Okay, some is really nice. The one that I show you just now, there's one that is really, really nice. This one, I like it. I really like this sort of work breakdown. It looks fantastic. So this sort of work breakdown, you see 1.1, 1.1. You know, 4.2.1, just beautiful. I mean, I like this sort of work breakdown. And the leveling one was also good. the first top one here, I think the numbering has problem. This one, the numbering and the description all have problems, you see. So maybe I will list it down, sample 1, sample 2, sample 3, you know, and I'll point out to you. Yeah, let me do that. I'll point out to you what is good, what is not so good about this. But then the samples is, you also can look at the samples in terms of how they list down their resources. I mean, this is very important as well. How they attach the resources to the work. So they've got different ideas. So meaning that there is samples for you to follow. I am giving you samples to follow. But if you do have your own ways of doing it or your own ideas of doing it, I've got some people doing it. I've got some students, they come up with very interesting layout of the resources attachment as well. You know, some of them even try to do formulas, you know, and then they use Excel to do formulas on it, and then they end up keeping that, and the next time when they go back to their own company, they can use their own method, and they key in certain things, you know, and then they can actually come up with the numbers by themselves. I mean, I've seen some examples like that, and I like it, really appreciate that as well. Yeah. This is the level one that I like. So later on, I'll put here sample 3, for example, good work breakdown, you know. And this is actually a good material, machinery, manpower loading as well. Basically, there's about 3 samples here, plus this one, there's about 4 samples. This one basically is the step-by-step all the way down to scheduling. Yeah, scheduling. This samples is scheduling. Maybe I will leave it to Dr. Lee to show it to you better in that sense. Otherwise, I'm like jumping into her things, and it may be a bit too confusing for you guys. Okay, so I will show you on work breakdown. I will show you this one. I'll post this one on eLib as well. Yeah. Okay. Right. So yeah, finally, you understand work breakdown now, isn't it? I mean, like, I think you've got a good idea. I'll show you some examples, you know, and how to use work breakdown. First, you to use attach resources to it, and then after that, we'll be working out on time, cost, quality. Next week classes, I will explain to you on quality management. It's project quality management. I will be sitting with you on Sunday morning around 8 to 11. So I will do one session with you. Okay, and then the other sessions, I will prepare a pre-recording with you. So Sunday afternoon from 12 to 3 p.m., you will have no class with me, but I will take your attendance nonetheless, so that we have no issues later. But I will prepare, instead of us having a class and you see me for 6 hours, it's going to be very, very tiring. So what I will do is the second half, like from 12 to 3, I will give you pre-recorded. Is that okay? Okay, so we have a class in the morning, and I will start to tell you how to do, how to work on specifications, how to work on drawings, and how to, you know, how to actually attach that with work breakdown. So whatever we're learning today on work breakdown, you will see me applying it next week in quality management first. Okay, and then the following week, Dr. Lee will show you how to attach resources, because next week, her class with you will be on engineering economics, yeah, to finish up on our scope management. So with the engineering economics, you get a good skills to do rational decision making for your client, because it's only with numbers, whether you're really making money or whether there's a return or the cost and benefit and all that calculated properly in engineering economics method, then you tell the client this option is the best, or yes, this project is necessary to be going ahead. The client make the decision based on rational information, not just what you feel like, you know, and what you think is good. So there will be proper numbering, set of numbering for you to tell your client this is your best option. But whether you choose it or not is up to them. Definitely, because it could be the best options in terms of numbers, but if the client don't like it, they have to make a decision. But at least you as an engineer, you have to tell them, this is what is best for you based on the numbers that we have calculated. Okay, this is our job. Whether they take it or not, it's their problem. Okay, but of course we will try our best to convince them lah. But if they're still not convinced, we also have to help them to develop their selection of the option. So once you've got your option being selected, okay, here I put in value engineering. Same, I will also do you a pre-recorded lecture, which is about half an hour to 40 minutes, I think, on value engineering. What is value engineering? In terms of scope management, it's important to do value engineering, especially when you're doing your work breakdown structure. Once the work breakdown structure is out already, besides studying the technical information for you to do the design, it's also very important for you to look at the cost of every component versus the value, versus not value, versus the, I wouldn't say quality, versus the performance of that component. If something that is 200 by 200 can do the job, you design it 300 by 300, it is not going to give you a higher value, because cost of 300 by 300 will be a lot higher, but the performance does not increase anymore. So for us as mechanical people, as manufacturing people, it's equally important for you to learn value engineering. When you're designing every single component, you need to study whether that particular component is actually performing, what is the output of that component, what are the performance given for that component, okay? Then what is the cost of that component? Cost over performance is value. It's called value engineering. So you may want to change your component sizes, you may want to change your components material to reduce the cost, but having the same performance, then no, sorry, is it performance over cost? Value is what? Let me see. Cost over performance, I think. I need to check my notes, but something like that. Okay, let me go. Let me go and take my notes and take a look. I don't want to give you something wrong, then you're confused later. Okay, no, this is EM class. Okay. Sorry, performance or function, performance over cost. No wonder I feel like I've said something wrong. Okay, so yes, whenever you do value engineering, you need to look at the performance. If let's say you can reduce the material cost or the cost of the component in terms of construction or in terms of materials, in terms of sizes, and then, but you keep the performance because the performance formula is on top. So on top, if the performance remains the same, there's a drop in your cost, then your value goes up, you see? Either way, or you maintain your sizes, but you have to make sure that that sizes or that material will give you higher performance than the other options. So this one here, when you're doing, the best is to do it during project. The latest you have to do is during project design stage. And a lot of consultants, they do not want to do that. Is because for consultancy, the project value they take the consultancy as percentage of the project value, 5%, 5.8% of the project value. If the project value end up to be 10 million, then your consultancy is based on 6, 5, 6, 7, 8% from that value. So a lot of consultants, they refuse to do it because if they try to make the project cost lower, they are actually not doing themselves a favor. So I think this has to be done usually from the client's engineers. So value engineering, we do it while the design is ongoing, while the client's engineer are viewing the design, while you are studying your consultant design, you have to carry out value engineering. Or during when the work breakdown is out, okay, and when the design is ongoing, you do it together, okay? Or you can even do it during preliminary design as well, as long as there's some form of calculation on some performance, and then you have some preliminary costing, you can do value engineering. But the best stage or the easiest stage to do is at the same time the design is ongoing, but not done by the consultant. There are separate consultancy doing value engineering nowadays. As supposed to be as responsible engineers, we need to give our client the best value for money. But unfortunately, the world is practical. We are not very kind and noble people all the time, okay? And we want to make money and retire early. So many of us would not bother with it, especially when you're a pure design company, okay? But if there is a request by client themselves for you to do it, then obviously you have no choice. But they will not take it seriously. Honestly, leaving it to consultant engineer, they will not take it seriously. Like, for example, I told you guys, all the rural water supply, everybody is just treatment plant. They will design the maximum, the full set service of treatment. They do not care whether the water is already super beautiful, it's already like spring water, it's already like Borneo, Puncak Borneo air, you know, it's really nice and clean. You only have to do minor filtering or do some treatment on the odor or whatever, and then it's as good as it to drink already. They don't think like that, okay? So that is already no value engineering involved. You know, like say supply of electricity, they will give you the full set of generation. Why? You know, maybe you don't even need that much, but they will give you that much. So then the value is not there. And you have not only the value is not there, sometimes you over design so that the project value is high. And with drainage project, it's the same, you know, with mechanical projects, the same, the pump, the valves, you know, the performance of the valve is needed as this much, future project is this much. So you design a valve or you design a pump that can perform this way. But when you do the costing bit, if it's high, then your value is low. So you need to study whether you can change certain components there so that it will still perform that way, but the cost is lower. Or you can take out certain components or make certain components with certain material that is not so bad, that is okay, that still can last 10 years because that is what your client wants, 10 years. So why do you want to go and make something that is 50 years when they only want 10 years and then end up with a high cost, performance still the same? Then your value drop. You see? Same goes with people designing, you know, composite structures, polymers or whatever. You need to look at the different components and see what can be changed, what can be altered, what can be option, you know, what can be different. But now we're talking about very technical into the product itself. We're not talking about options with options, okay, of whether, you know, overall options. This is about you have already confirmed on a product itself. You want to value engineer it to make sure that the entire project will have a very high value, meaning that either the cost is good, low, the performance the same, or performance is succeeding way beyond the cost that is providing. So that is the aim that we are looking at for value engineering. Okay. A lot of government agencies, they will force you to design. They will post about 50 million and above in Malaysia. In Sarawak, we're talking about value engineering. It's a must already. But when you depend on just normal consulting engineer to come in and do value engineering for you, I think it will be a miracle if they will come up with anything serious. Okay, serious. I mean, they will do it, but not serious about it. Okay, So it's better for like JKR themselves, or the authority themselves, or the developer themselves, or the client themselves, to have their own engineers trying to monitor value engineering. When every part of the design comes, you check, you ask what can be done better, what can maintain the performance but lower the cost. You keep on repeating, asking that kind of questions, and then you will start to see that your design will be more and more minimalistic, more and more cleaner, more and more less time consuming, more and more cost beneficial, and performance may be the same, or some of it you may design it, just put in something simple, cheap, but then the performance goes straight up, and then you have a better value. Okay. Right, the last bit is about scope change. So obviously, once the project is done, you've designed, you've done your value engineering, the design is finished, then we are going out and build the thing, or carry out the facilities. Then when we're doing the execution, our job as engineers is to do monitoring. You have to check, you have to do tests. For manufacturing people, many part of the production line, you have to come up with testing work. Okay, you have to do tests, okay, to see whether it passed certain acceptance criteria, certain limits, And for us as civil engineers, we have to make sure that when we do, when we want to build something 15 meters by 4 meters, you don't end up with 12 meters by 3 meters, kind of thing. And then, or sometimes we make mistake, we have to change we have to go back and change design, and that could be what we call slowly our scope will be going out of control. We have what we call scope creep. Scope creep is basically saying that slowly, bit by bit, your project are losing. It's going derailing. It's going away from your original design. So it's very important for us to be very disciplined about this, okay, about scope creep, to make sure that when we're doing monitoring work, we always monitor very closely with technical. Yeah, we always monitor very closely with time, cost, quality. Definitely, it's something that we really are very always on it about. But you have to understand, when you're doing monitoring work, for example, quality and scope. These are two things that is related to scope creep. Okay, time cost not so much, but when scope itself, when you have technically something that is not right. For example, you do piling and then it goes 2 meters, sengek, you go 2 meters slanting, your power goes down, it goes off, and it's not right. So what do? Do you do a bigger power cap, okay, or do you leave it as it is? And then basically, if it's slanting, then you're actually losing the strength, of the foundation. So those are scope creep. So if let's say technically we see that, it's very easy for us to comment straight away, then and there, this is wrong. Okay, we've done tests on it, this is wrong. But the issue is, how do we make it better? And many times, we engineers lost our discipline. Meaning that when the contractor says, we tell them that please come up with an alternative proposal of how you can rectify this situation. They don't come up with it. They drag their proposal. You ask them for it 1 week. Oh, next week I give you. Then they don't come up with it. And then you see them, they run away from you. Okay. After a while, you get tired of asking. Yeah, you get tired of asking. I just recently had a project. It's same thing, the piles. It's a group. It's a pile kit that has 2 pile group and 3 pile group. There is a few locations the pile is already slanting. This has already been 4 months. I mean, we've been talking about this 4 months, okay? And the contractor actually gets external engineers to calculate whether they need to increase the pile cap so that the loading will still be the same, the capacity will still be the same. So because this contractor, they refuse to pay the engineers doing the calculation, so that they don't get that proposal. Okay, they don't get the alternative calculation, or that they don't get a proof calculation that this is still okay. Up until now, first 2 months, the RE asked for it. Up until now, the RE is sort of forgetting about it. too many things ongoing, ma, forgetting about it already. So then we really have to remind them, you know, it's like, you know, you are the RE, you know, at the end of the day, if one location is like that, okay, you can close one eyes. 2, 3, 4, 5, 6, and then you've got 100 power caps, and then, you know, 50 of the power caps, these people are doing it wrong, and there is no proof that this particular loading is actually, this capacity is actually correct. You know, don't tell me that you guys are going to forget about it. Is it? So we have to go by other means already to make sure that we get the calculation into our book. If not, then if something happens, you really have nothing to back you up. So it's a very serious problem. And I think this scope creep is exactly this. Slowly, you get tired of asking. Slowly, you get tired of following up. And after a while, because so many things on site is ongoing, the building is up already. So can you imagine? First foundation, something wrong? You ask for the calculation, you ask for the alternative proposal, you ask for the rectification. It's not being done, but everything goes up, 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 up. The whole building is up already. And then when the calculation do come and it's not okay, then how? Take off everything again and redo it? Okay. Yes, every engineering calculation do have limit. Okay, we do have factor. We do increase things. But we need to know, even with the factor, some of the mistake that is being made that is not rectified will not be able to carry through that factors, you know. Our job is to deliver this project with integrity, whatever you design it to be. The quality bit of things has to be according to the scope of work. You do not allow it. You have to be very disciplined. Your team has to be very disciplined in carrying out the checking, carrying out the request, and or even demands, you know, of rectification to make sure that it's done properly. Honestly, I'm from a contractor background. I can understand completely what contractors are like. Okay, I have many years in contracting. In contracting, I understand one thing. It's not that the contractor wants to cut short. It's not the contractor wants to play funny. It's not the contractor wants to be nasty. It's not the contractor is lazy, you know, or want to cut costs. Yes, some contractors are all of this and more. But there are many contractors because the site is a big site. Okay. Pan Borneo is a very long site, hundreds of kilometers. Dia tidak sempat, they cannot, they don't have the ability. I mean, I wouldn't say you must have the ability to be the contractor lah, huh? Okay, that is a must. You cannot say you don't have the ability, but they don't have the ability to be 100% perfect because there are workers who are not perfect. Their material were not perfect. There will be bound to be some little fishes that will get off, that will escape. So it's the controlling and monitoring team that is very critical. You're there not to go on the site drinking coffee. You have to go and check. And when things are not correct, you have to report. You have to make sure that the NCR is being done properly. Contractor needs to comply. Your job is to help him to comply. You have to make him understand that it doesn't look like a serious problem, but all these little problems that are not serious will all add up to be a big problem. And then one day, the whole building collapsed, or one day, the bridge collapsed, or one day, one part got sengek, the wall, the baling. I'm sure a lot of stories in China as well, where you have walls that, you know, the whole building collapsed, you know, the whole thing just went haywire. I mean, these are all because of scope creep. It's not people purposely go out there and do it. I mean, I don't go into construction project wanting to do a bad job. I want to do a good job. It's just that on site, my man, you know, they are not educated people. Okay, they are not educated people. How do you expect them to understand from your perspective that this is only 2 mm difference or this is 3 cm difference and you make a big noise on it? You have to make the other side understand, not only the workers. The workers don't understand. Okay, scope creep is like that. Slowly, one day you wake up, things are different already. The disaster happened already. That is the purpose that we have to do very serious discipline monitoring work. And maintaining the progress, reporting on the progresses, maintaining on the checklist for the quality, safety. You have to make sure that you check through everything. And then the monitor is one thing. You have a good, diligent people, young engineers go to site. They, young, energetic. They drive around the site. They can do a lot of monitoring work. That's fine. But controlling work is done by the project manager. If something is not right, you have to have the discipline to call for a rectification, or call for adjustment, or call for extra testing, so that make sure that, or extra calculation to make sure that even though that little bit of change will not create a big issue later. Okay, so to manage scope creep, controlling is very important. Monitor is one thing, controlling is another thing. Controlling is you look at the data, something is not right, some actions need to be taken. So there's no point of we going down to monitor, you keep it in your files, keep it under your table, and then you forget about it. Controlling work are not done. When you say controlling work are not done, it means that there's no action taken to bring it back to its original position. And it doesn't have to be taking down the building or doing something drastic. It could be adding some bracing, adding some additives, or adding some materials, or putting in or doing, like I say, some of the calculation, that to see that, you make the pocket bigger, and then to see whether the loading capacity is still equal or about the same, or off by how much. At least we can tell what is allowable or not allowable. That mistake is allowable or not, you see. So those calculations or extra sending things to lab to test to make sure that even though it's not that much, but at least we can still maintain a certain level so that you are comfortable with the rectification work. So not all the time you need to have special rectification work, or like drastic rectification work. Some things maybe, like I said, contractor, we're not perfect people. So you cannot expect perfection. You cannot expect contractor to be perfect. The machineries are not perfect. The excavator drivers are not perfect. The people are not perfect. The environment itself is not perfect. Not like factory environment. If you do precast concrete, if you do IBS, all these things, they are computerized. They are made to perfection. It's not affected by weather. It's not affected by ground conditions. It is easy to put it as 99% perfect. Here, it's impossible even to achieve 99% perfect. Any civil engineering project, if you got like 80% to 90%, you are like, if you got 90%, you are a really A-grade contractor already. If you can get 80% of perfection, minimum mistake, you're quite good already, okay? And designs are not perfect too, like what Nick Man says, completely, I totally agree. I practiced as consultant before. I know my designs are not perfect because a lot of time I have to I am not at the site. The information are not complete. So, but I have to get the design out first. So when that happens, I need to be very careful, to see whether it's doable or not on site. And if it's not doable on site, I need to be ready to change or to alternative to change the, not to change the scope, but to change that work package or to rectify the sizes and all that. But when it comes to that, the engineers have to be responsible for the change in that sense. Yeah, definitely designs are not perfect. I mean, even if you check like 20 times with 20 different engineers, it's just like your report. After you read it like 20 times, when Dr. Ting reads it, I will still find grammatical error. I'll still find that you do something wrong. You see, so too bad. That is the way it is. Drawings is the same. You can check it like 10 times, 20 times, but does not mean that you don't check, don't say that because I said that it's not perfect and therefore I get it out first, no need to check. You have to check to your best of ability, but admit that if there's a mistake, you are ready to rectify your design as well. The contractor also the same, if you're ready to rectify your work as well, especially when it is a mistake or a problem that is created by your site people lah. Yeah. All right, so this is about scope change control. The main word is scope creep here lah. One or two one-off problem, obvious problem is always not a problem. It's slowly things change, and that is the worst. Okay, I think this is what I have for today. Any one of you have any questions? We can open up for questions now. Let me off the share screen. I am sharing, right? You can see my slides, right? Okay. I haven't been sharing my notes. Yeah, I'm sharing my screen bar. What's going on? Yes, it's sharing. Oh, it's scary. I got so totally scared for a while. Stop sharing. No. Okay. Okay. Right. Any questions from anyone? Anyone wants to show me their project or share with me your project idea? Basically, overall, we have finished on scope management. It's just that life cycle costing and value engineering are a component that is like blow up. One thing that I want you to learn more from scope management. And economics is another topic that is part of scope management, but we want you to learn the technique a little bit more. So this tool will be next week, okay? I will post up my notes. I'll post this one up first and then post up the value engineering and LCC as well. You can listen to it anytime. It doesn't have to be before engineering economics, but before you do resources management, please finish listening to all the recording. Finish reading all the scope management things first, okay, before we move on to resources management. So this is week 4 for us. So week 5 will be Dr. Lee doing economics, and I'll post up the notes also for notes and recording for LCC and value engineering. So that will completely finish our scope management. So week 6, Dr. Lee will come back in and talk to you on resources management already. So I want you to do your work breakdown structure, get your project and do your work breakdown structure before week 6. When she comes in, I want you to learn resources allocation. Then after that, you can show her. I mean, we really want you guys to show us your work, because we can comment, and it's commenting at no expenses or marks. Why not? Isn't it? It's not like you show us the work now and I say, this is so badly done, and then later on I give you lower marks, No, it's not like that. We would just try to improve it so that you can get at least 45, 40 out of 60, Then it's easier for you to pass. Our passing mark is 60 marks, people who doesn't know, okay? Our old students all know, passing mark is 60, but if you get every subject 60 marks, 60 to 64, which is a B mine, I think. Is it a B mine? Yeah, it's a B mine. If you get 60 to 64 all the time, you cannot graduate one, I tell you, because that is your CGPA will be less than 3, And every semester your CGPA has to be over 3, If there's one semester your CGPA is lower than 3, you will be in trouble, okay? You'll get warning from Dr. Lim. And then if 2 consecutive semester your CGPA is less than 3, you will be stopped. You will be thrown out of the uni with nothing. I mean, like, that is the rule. And I haven't seen any students being successful trying to appeal and all that. None, okay? So you make sure that you score at least 65. If you're 65 and above, you're very safe. You're very, very safe. So that's why it's important for us to help you to get as much marks as possible with group assignment, with group project and individual assignments. Anything to anyone wants to ask me on their project? Have you all split into your groups already? Fourteen of you all have your own group already. Nickman, I see you already registered, huh? So you've successfully registered for all your courses with the denda 200 ringgit, is it? Oh, free, that's good. My student, she dropped one subject. Wow, yes, that's courtesy. My students pay 200 ringgit because she wants to drop her RP. Because for Masters of Engineering in Civil Engineering, our RP is 3 semesters, so she wants to drop it, and then she end up have to pay 200 ringgit. Okay, have you all chosen your project? Do you want to discuss about your project? If not, then we bye-bye already, all. Jessica, Juntek, you all contacted Ziyuan already?
Yeah, doctor, we actually had a WhatsApp group already, and then now I'm still searching for a suitable project for us to
So I
incorporate
think
both mechanical and civil. But I was thinking of doing a clinic or a hospital project because that will involve more of the mechanical parts.
yeah,
If I would choose a road project, there's not much for them to contribute
yeah,
also. So yeah.
yeah. Or you can search for treatment plant as well, treatment plant and water treatment plant project. People, that one also involves some mechanical.
Okay, okay. Thank you,
Yeah,
doctor. Yeah.
like raw water intake tank. Raw water intake tank itself also involves mechanical, got pumps and all that.
Yeah.
And then
But do we need to like can we create our own project or we look for like existing project, something like that? I was thinking or maybe would like to maybe make our own like project to incorporate both lah. If really like no other ways.
also, but I mean, supposed to be there's one part that you need to describe the project description and project background. You see, so if you don't have that, then you have to maybe to take some project and describe the site and all that. That's fine also. Yeah.
So it does not have to be like a real project lah, just that we just need to.
I want to see real projects, but if it's like the modified version of the real project, I think would be a better word for it lah.
Okay, okay, all right.
Okay. Because like I said, there's a portion of it, the report, that you need to describe where your project is and what does it have and all that. But if you modify from a real project, then it's a lot easier.
Yeah. Okay. All right. Thank you, doctor.
Okay. But remember, later on, you need to have quantity also. So the modification part, you don't want to be too ambitious until you modify too many things, or add in too many things that is not part of your original project. Then you have issue trying to calculate your quantity later. That is something you have to look out for, huh? If you say you modify and you have a pump house, and that is maybe okay, But then if you like half of it is your imagination or modification, then later on want to put down quantity, you have no quantity to put down, you see? Yeah.
Yeah, very hard to look for the rate as well. If like because we don't know the real rate.
Yes. Okay, so please confirm on the project and do your work breakdown by next week, huh?
Yeah,
the
okay,
work
sure.
breakdown, everybody, your work breakdown has to be ready before week 6. If you want to email me, by all means, email me and I can comment, okay? So when Dr. Lee comes, you already got the work breakdown. You are learning how to attach the resources only. Of course, you can show it to her. She can comment for you as well lah. Yeah, but the marker will be me. So I think it's better if you just email me, because next week I won't be having a class with you. I won't be having a class with you until like week, I think week 8 or something like that. Week 7 or week 8. Week 8, I think, yeah. So by then you'll be doing all these resources planning, time planning with Dr. Lee for the next 3 weeks, you see. Of course, I can pop by when the class is almost finished and also comment on your work like you want to, yeah. But I think email is fine, okay? Email me. You have my email? I will type it in the chat box, I really seriously recommend you guys to take the consultation carefully, because I've got previous students, they just don't take the consultation very seriously, especially the last intake, the October intake. Many of them didn't do well at all, you know, in some of our subjects. Me and Dr. Lee, some of pass, fail, and then we have to sit resitting and all that kind of, so tiring, you know, just because of they didn't take care when they're doing the assignments. Okay, and Ibrahim, who are you with, Ibrahim? Amira, where is Riley today? I haven't seen him for 2 weeks, Amira.
I think he's working. He didn't.
You better tell him to read, go through the recordings carefully. Don't ding ding dong dong later on cry. I don't know.
Okay, I will let him know, doctor.
You are combining with him, right?
Yes.
And any other group member?
No more. No, not yet.
Ibrahim, who are you with, Ibrahim?
Doctor,
Yes.
actually, we are still looking for groups. I mean, me, because some of them from mechanical and some of them from like other departments. So we only have maybe 2 or 3 for civil. So maybe I will be with them if they are okay. Like
There is many from civil. There's so many of us from civil here. Don't say you don't have enough civil. Nickman is from civil. Jessica,
I mean, we have
got groups from civil.
yeah,
I think
we 2 or 3 from civil, I think.
wow, who else? Afika is also from civil. Melissa is also from civil, right? QS and all that. Hey, don't give me an excuse that there's not enough of civil people. There's plenty of civil. I'm worried about those people who are not civil. You better look for a group soon. I mean, I'm not joking here. This is very different from undergraduate studies. You get any CGPA, you can bye-bye and go out.
All right, doctor. Today I will find.
Yes, you have to confirm on a group and sit down and get a project and who is getting the project and who is working on the work breakdown and all that. You guys need to meet up and start to work on it. Okay, I'm serious about this. Who is me? Let me see. Shasha. Nickman. Shasha. Shasha, you are from which one again? I forgot. Sorry, there's too many of you.
Management.
Sorry.
Management.
Which industry are you from?
Industry. QS.
QS. You see, this is civil people also. Nickman. Ibrahim, you want to join them? They have one more space.
You can group with me and Nickman. Okay.
Yeah. Okay, so you embarrass yourself, Ibrahim, there's an offer here already. Nickman and Shasha is willing to take you.
All right, doctor. I will be with them in the group, yeah.
You go and communicate with them,
All right.
Doing this online, there's no excuse as all that. There's nothing that we can accept here that says, oh, sorry, I cannot find a group. If you cannot find a group, it's fine. You do your own work. You can give me a solo assignment. I'm fine, okay? Afika, Melissa, I know Victor, you're resigning, am I
right? I'm with Zainuddin and Melissa.
Oh, Melissa, you're from the hospital group, am I right?
Electrical.
Electrical. Okay, so electrical, Victor and Zain. Zain is from construction. Victor, you're from oil and gas, right?
Yes, yes.
I think you all can find something like in between now. How that has a bit of that has a bit of electrical as well. Like how we in it, huh?
Okay, okay.
Okay. Africa, Africa, you're quiet. Are you with anyone?
Yeah,
2, 4, 6,
I'm
8, 10.
I'm working with Aisha, Prof.
Aisha, huh?
Yeah,
Are both of you from which gang?
civil.
Civil. You see, Ibrahim, 2 or 3 from civil. Come on, there's so many from civil. Like I said, I'm worried about people from electrical, people like Ziyan, who is from polymer, Ling Jun Tet, who is mechanical. There's only 3 or 4, 2 or 3 people who are not civil, but all of them are civil. Amira is not civil, I know, yeah. Riley is also a QS from civil. So both of you are from civil, huh, right? Africa.
Yeah, Prof. Yes.
Have you chosen your project yet? It's just the 2 of you, right?
Yeah, we are still discuss. So hopefully we will get our project soon lah.
Yes, yes, yes.
Okay.
Where is Aisha this morning? Not here, is it?
Aisha outstation. So
Oh,
uh,
okay.
she is not be able lah. Later I will inform what is the things that is going on today.
Ask her to listen to my this one. I normally will post it on YouTube and then I'll put the link. So you just click on the link, then you can straight away listen it from YouTube already, lah, huh?
Okay.
Ask her to go through this recording. I know some students are very lazy. They don't want to go through this recording because it's really long as well, you know. So they're like, never mind lah. I just read the notes lah, you know. Cannot, you know, if you don't attend classes, people like Riley, Zainuddin, all your friends, please tell them, please go and listen to the recording, so that they get an idea.
Yeah.
Those of you who are unclear about certain things, also you have to go back to the recording. The purpose of the recording is to give you more time to understand the lecture, you know. It's not there just because Dr. Ting likes to become a YouTuber, you know. Yeah. So yeah, YouTube, this thing on YouTube also, I only share it with my students only. It's not open in public as well. Yeah. Okay, I think everybody's got a group. There's nobody missing. I want everybody to have confirmed on the project by next week and start to work on your start to sit down, you know, do your own Zoom, you know, or your discussion. You have to, and whenever that you have discussion on WhatsApp, whenever you have discussion, this is very important. Another point that I want to tell you, whenever you have discussion on WhatsApp, let's say you got like discussing things, not to say when we discuss appointment like that, no need lah. But then if let's say you're having some discussion on WhatsApp or some form of Zoom meeting or WebEx meeting, I want you to screenshot it. Okay, screenshot it, and at the end of the semester, hand it in together with your report. Okay, why? Because I need to make sure that everybody is working in a group. Okay, even though I'm not going to penalize people or entertain any complaints about members who are not working, but at least if you do have the proof that every time you do a discussion, this guy is not around, then you have a very strong case, okay? So I want you to put it in your appendix, all your meeting with one another, okay? Just a screenshot lah, you know, and then you just copy and paste into your A4 sheet, and then later on you just, you know, because your report will be via it will be via PDF, you know, via soft copy through eLib as well. So no cost at all to you guys, yeah. But it's a good record of everybody working together in the environment, in that sense, yeah. Especially for group project, because there is a part that we need to see your team work, All right. Anything else? I know all of you are like, oh yeah, I'm still looking for a project. I'm still working on it. Amira, you have a project already? Does Riley give you a project already? Are you
We
still searching?
but both of us are still searching. He's still searching. Yeah.
Yeah.
Okay.
Yep. All right.
Okay.
Hey, Amira, I've got people wanting to buy fly ash. Your company sell fly ash, right? Do you sell fly ash?
Fly ash. Microsilica, is it?
I think so. Is that what is the formal name for fly ash? I only know it's fly ash.
Silica film. Yeah, we sell it. We sell it to Elcom Singapore. Can contact our sales if they want to buy, or if interested for research, can contact. We're willing to. We're willing to share.
Yes, yes. Can I give you? Can I give him? These engineers. I mean, like this engineer friend of mine. I don't know why he wants the fly ash for. I think it's probably for some research. His style is he wants to study something lah. So do you mind to give me your salesperson's number later on via WhatsApp, and I
Yeah,
will
sure.
forward it to him lah, huh?
Yeah, sure, can.
Yeah, yeah.
Or
Suddenly I
can
thought of that because the other day he asked me and I thought of you, but then I don't want to disturb you, you see. So yeah, since we are here, we just ask lah. Yeah.
because since I'm also working with byproducts also, so probably I can let you to the manager. He's actually doing some environment, so he's under HSE, also dealing with byproducts. Yeah.
Okay, sure. No,
Yeah.
no, you just give me your salesperson's number, the one that can sell the fly ash lah. Yeah, and see.
Sell. Or okay, sure, can.
Sell lah. Yeah. Or if you don't mind, I can give him your number.
Can. No
Can
problem.
huh?
Okay.
Yeah. Give me your number, and then I don't know what is his purpose like, whether it's by research or which part of research that he wants to do, or is it design? Because he is a consulting engineer. Yeah.
If he wants wet slag also can.
Wow, you sound like a salesperson already. Anything I can sell. Okay.
Yeah.
All right. So I'll give him your number lah, huh? You don't mind? His name is William lah, huh? I'll get him to contact you lah, and
Okay,
tell you
no
what
problem.
exactly that he's using it for lah, and then you can introduce him to the next person lah, huh?
Okay, sure.
Okay. Thanks,
Yeah.
Amira.
Welcome, doctor.
Okay. If there's no more questions here, we can take a off. All right. See you guys. Bye.
Thank you, Doctor.
Thank you, doctor.
Thank you, doctor.
Yeah, doctor.
See you.